An electrical substation is a facility that is used for the purpose of transforming voltage levels and distributing electrical power from power generators to consumers. Electrical substations receive high-voltage electricity from power plants or transmission lines, and they transform it into lower voltage levels that are suitable for local distribution to homes, businesses, and other consumers. Substations typically contain transformers, circuit breakers, switches, and other equipment that are used to regulate and control the flow of electricity. They may also include monitoring and control systems to manage the flow of electricity and ensure that the system operates safely and efficiently. Electrical substations are typically located near populated areas, where there is a high demand for electricity. They play a crucial role in the overall operation of the electrical grid, helping to ensure that power is delivered to consumers reliably and efficiently. The primary function of a substation is to transform high-voltage electrical power into lower voltages that are suitable for distribution to homes, businesses, and other consumers. More specifically, the functions of a substation may include voltage transformation. Substations are designed to transform high-voltage electricity, typically ranging from 69 kV to 765 kV, into lower voltage levels that are more appropriate for local distribution, usually between 4 kV and 35 kV. Load management. Substations also help manage the load on the electrical grid by controlling the flow of electricity and ensuring that it is distributed evenly to different parts of the network. This helps to prevent overloading and reduces the risk of power outages. Protection. Substations contain a range of protective devices, including circuit breakers, fuses, and other equipment that are designed to isolate faulty equipment and prevent electrical accidents. Monitoring and control. Modern substations may include sophisticated monitoring and control systems that allow operators to monitor the flow of electricity and respond to changing conditions in real time. This can help improve the efficiency and reliability of the electrical grid. Switching. Substations also serve as switching points for power transmission and distribution. This means that they allow power to be routed through different transmission and distribution lines as needed to ensure that power is delivered to consumers efficiently and reliably. Reactive power compensation. Substations may also include equipment such as capacitors and reactors to help manage reactive power in the electrical grid. Reactive power compensation helps to stabilize voltage levels and reduce power losses, which can improve the overall efficiency of the system. Emergency backup power. Some substations may be equipped with emergency backup generators or battery storage systems to provide backup power in the event of a power outage or other emergency situation. Electrical substations can be classified in a variety of ways, depending on their functions, voltage levels, location, and other factors. Here are some common ways that substations may be classified. Voltage level. Substations can be classified based on the voltage levels of the electrical power they handle. For example, a substation that transforms high voltage power, typically above 69 kV, into lower voltage levels for distribution may be classified as a transmission substation, while a substation that transforms power from the transmission system to even lower voltage levels for distribution to homes and businesses may be classified as a distribution substation. Function. Substations can also be classified based on their functions. For example, a switching substation is one that primarily serves as a switching point for power transmission and distribution, while a load-serving substation is one that is designed to handle a specific load or set of loads, such as a large industrial facility. Location. Substations can also be classified based on their location in the electrical grid. A primary substation, for example, is one that is located at the beginning of a transmission line and receives power directly from a power plant or other generation source. A secondary substation, on the other hand, is one that is located downstream of a primary substation and receives power from the transmission system. Design. Substations can also be classified based on their design characteristics. For example, a conventional substation may consist of outdoor equipment installed on a fenced-in platform, while a gas-insulated substation GIS, may use compact, sealed equipment that is filled with a gas such as sulfur hexafluoride, SF6, to reduce the size and weight of the substation. Ownership. Substations can also be classified based on their ownership. A utility-owned substation is one that is owned and operated by a utility company, while an industrial substation is one that is owned and operated by an industrial customer, such as a large manufacturing facility. Classification of substations based on voltage is one of the most common and useful ways to categorize them. Substations can be classified into the following categories based on the voltage levels they handle. Extra high voltage, EHV, substations. EHV substations are those that handle electrical power at voltage levels greater than 230 kV. These substations are typically used to transmit power over long distances and may be located near power generation facilities or in remote areas. High voltage, HV, substations. HV substations are those that handle electrical power at voltage levels between 69 kV and 230 kV. These substations are typically used to transmit power over shorter distances and may be located in or near urban areas. Medium voltage, MV, substations. MV substations are those that handle electrical power at voltage levels between 4 kV and 69 kV. These substations are typically used to distribute power to residential, commercial, and industrial customers and are often located in urban and suburban areas. Low voltage, LV, substations. LV substations are those that handle electrical power at voltage levels between 100 volts and 4 kV. These substations are typically used to distribute power to residential and small commercial customers and are often located in residential neighborhoods. Substations can also be classified based on their configuration or layout. Here are some common classifications based on configuration. Conventional substations. Conventional substations are the most common type of substation and consist of outdoor equipment installed on a fenced-in platform. They typically include a transformer, circuit breakers, switchgear, and other equipment to manage the flow of electrical power. Gas-insulated substations. GIS. GIS substations use compact, sealed equipment that is filled with a gas such as sulfur hexafluoride, SF6, to reduce the size and weight of the substation. This type of substation is often used in densely populated urban areas where space is limited. Mobile substations. Mobile substations are self-contained units that can be easily transported and installed in temporary locations. They may be used to provide backup power during emergencies, to support construction or maintenance work, or to serve as temporary substations during the installation of new permanent equipment. Pole-mounted substations. Pole-mounted substations are small substations that are mounted on utility poles. They are typically used to serve small loads, such as residential neighborhoods or commercial areas. Underground substations. Underground substations are built underground to save space and reduce visual impact. They are typically used in urban areas where space is limited and visual impact must be minimized. Substations can also be classified based on their application or intended use. Here are some common classifications based on application. Transmission substations. Transmission substations are used to transform high-voltage power, typically above 69 kV, into lower voltage levels for distribution. These substations are typically located at the beginning of a transmission line and receive power directly from a power plant or other generation source. Distribution substations. Distribution substations are used to transform power from the transmission system to even lower voltage levels for distribution to homes and businesses. These substations are typically located downstream of a transmission substation and may be located near or within urban areas. Load-serving substations. Load-serving substations are designed to handle a specific load or set of loads, such as a large industrial facility. They may be located near or within the facility they serve and may be designed to handle specialized equipment and power requirements. Load-serving substations. Load-serving substations are designed to handle a specific load or set of loads, such as a large industrial facility. They may be located near or within the facility they serve and may be designed to handle specialized equipment and power requirements. Converter substations. Converter substations are used to convert power from one voltage level or frequency to another. They may be used to convert power from DC to AC or vice versa, or to convert power from one AC frequency to another. Switching substations. Switching substations are primarily used as switching points for power transmission and distribution. They may be used to switch power between different transmission lines or to redirect power to different distribution feeders. Overall, the classification of substations based on application is important for understanding their intended use, the equipment they require, and the locations where they are likely to be located. This information can be useful for planning and designing electrical distribution systems, as well as for selecting appropriate equipment and maintenance strategies for different types of substations.